Intramembranous ossification is how we form flat bones. So, for example, the bones of your skull or your clavicles. So ossification is, os is bone, and ification is forming. So this is a forming of bones. This produces flat bones. So in this first step here, number 1, we have mesenchyme. That's the tissue that comes from your mesoderm, the middle germ layers of the body. So this would be happening as an embryo. So this middle germ layer tissue starts to form into kind of soft sheets of tissue lined with blood. So these are blood vessels, and then this is tissue. The lining of these blood vessels gets covered in a single layer of osteoblasts. So these are osteoblasts. Those are those cells that create bone tissue. So those osteoblasts are going to start to lay down bone tissue, and that's these little blue lines here. So you can see everywhere that we had a blood vessel, we've got it lined with osteoblasts. Here's the osteoblasts. And these osteoblasts are laying down bone tissue, kind of in layers. If we let some time go by, we get over here to number 2. This is zoomed out just a little bit. The bone tissue that was layered down originally has now started to harden into bone tuberculae. So those are going to be the spongy bone inside of the flat bone. And we still have that layer of osteoblasts lining the blood vessels. Notice the blood vessels are a little smaller here because there's more bone tissue. And they're laying down layers of new bone tissue here. Same thing here. Here's my osteoblasts laying down some new bone tissue. And you can start to see some of these cells have been trapped in this bone tissue. So these are some of our first osteocytes. Let a little more time go out. This third and fourth picture are kind of zoomed out. So imagine that we're looking a little bit further away at this point. So now we're on step 3. And we have formed the spongy bone in here. This is hardened. And on the outside, we've got more mesenchyme. So that's the embryonic tissue. And this is going to start to condense to form the periosteum. Remember, the periosteum is on the outside. So this is going to be the top of this bone, and this is going to be the bottom down here. And then over time, that periosteum layer is going to lay down some more osteoblasts in lines, and that's going to create our compact bone on the top and our compact bone on the bottom. And then we have our periosteum lining again on the top and on the bottom of the flat bone. The next type of ossification is called endochondral. So endo means inside, chondro is cartilage, and then ossification is bone forming. So endochondral ossification means that we're going to form bones, but we're going to start with some cartilage inside. And most of our long bones start as a cartilage precursor, as an embryo, and then as we develop, they begin to harden into actual bone tissue. So in our first step, our mesenchyme tissue, so that's our early germ tissue, is going to start to form into these hyaline cartilage precursors. So these are going to be similar in shape and size to what the final bone is going to look like. And so here we're going to follow a bone from one of the fingers. All right, in the center of this cartilage, we're going to start to find some chondrocytes. So chondro means cartilage, cyte means cells. So these are cartilage cells, and they're going to get larger, and this is going to form the primary ossification center. So this is where we're going to start to see the bone formation begin in the center here. These get larger, and then these cells die. So these cells are going to die, and then this space begins to calcify. Still a fetus at this point. We're starting step 3. So where we had the primary ossification center, it calcified, and now the osteoclasts have come in here and removed that bone tissue. So we now have a marrow cavity, and you can see this blood vessel coming into this marrow cavity. And we're going to start to see a secondary ossification center form in the epiphyses. And if this bone has a second epiphysis, it might form down here. And then these are going to do the same thing that the original ossification center did, where these cells will get really large and then they will die off and then calcify. Number 4 is what bones look like at birth. So this would be an infant that was just born. The secondary ossification centers start to hollow. We've got osteoclasts hollowing out these centers. 5 represents what the bone does as a child. So we can see there's still some cartilage on this end. And then on this end we have what we're starting to see as an epiphyseal plate. So this epiphyseal plate is where this bone is going to be able to grow longer. So we've got some fully formed bone here on the end. This is in an articulate, so here's some articular cartilage on the end. And then this epiphyseal plate is going to allow the bone to grow in both directions to elongate. And we'll look at this more in detail on the next slide. Bones become fully formed in late teens to early 20s. So now we've got no more cartilage in here. These bones have stopped growing. You can still see the epiphyseal line right here. And this is going to be where the spongy bone looks fairly dense. That's a remnant from the epiphyseal plate. The only cartilage that's left at this point is the articular cartilage on the ends to allow the joints to move smoothly. Marrow cavities have completely united into one. So this marrow cavity completely connects up to this marrow cavity, and now there's only a single marrow cavity inside of the entire bone cell. So bone elongation is how bones go longer. And what we're going to see is this metaphysis, which is in the epiphyseal plate. And this is going to allow this bone to grow this way and this way. And this metaphysis is made up of 5 zones. I like this slide. This makes a good essay question on the test. So let's start with zone 1. So zone 1 is in the cartilage. This is called the zone of reserve cartilage. So this is all pretty much hyaline cartilage. That's a 1. Hyaline cartilage. This is in the epiphyseal plate, and it has not yet started to harden into bone. Zone 2 is about here. So zone 2 is the zone of cell proliferation. So proliferate means many. So proliferation is where we're going to do mitosis. So what you can see is there's a lot of really squished cells in here, right? So these look really small and squished. What's happening is these cells are undergoing mitosis, but they're not really growing any larger. And then as these cells move into the zone of hypertrophy, so that's right here, this is zone 3. So these are going to get larger. So hypertrophy, we talked about this. Hyper means bigger, more. And so now look at the size difference. These cells are tiny and these cells are much larger. And then we've got this zone of calcification here. So this is zone 4. And what happens here is these large cells are going to start to die, but before they fully die, they're going to calcify and harden. And so that's going to preserve their shape so that when they die, they have some support for the cartilage. And then zone 5 down here is the zone of bone deposition. And this is where the chondrocytes are going to actually die off, and the osteoblasts are going to start to line. So this is going to create spongy bone. And that's why it looks very similar to that intramembranous ossification. So when bones grow larger, they don't just grow longer, they also grow wider and thicker. Otherwise, they wouldn't be very supportive. So appositional growth is the growth in diameter. So diameter is across, and then thickness, right? So thickness is how thick is this bone. This occurs by intramembranous ossification. So this is the same way that we make those flat bones. And what happens is, this is an infant, and so we're going to ossify more bone out here, and at the same time we destroy the bone that's in the center. So this is going to widen the medullary cavity in the middle at the same time as it widens the bone at the edges. And over time, you're going to see going from this thickness to this thickness in an adult, and then the diameter in this adult cell is much like 2 times what it is over here in this child's bone. And so as our bones grow longer, they're also growing wider and thicker. And our bones don't stay the same shape or size all of the time. So Wolff's law states that the bone architecture, right, so its shape, is determined by the mechanical stress placed on it. So the stress is its function. So if we change what we're doing with our skeleton, it's going to change its shape to match what it needs. It's estimated that about 10% of the skeleton is remodeled every year. So imagine we've got this femur, and you can see how it's kind of got this curved shape like this. And maybe this person is going to start running, or they start walking differently, and the stress that's occurring to this bone changes. Maybe there's more stress added on this side now for some reason. Well, what's going to happen is it's going to remove bone over here where there's less stress using osteoclasts, and we're going to build some new bone over here using osteoblasts. Remember that stress causes osteoblasts to start laying down bone tissue. And then over time, this bone shape has changed. This is much straighter now. So it's going to better deal with the stress that was being put on it. Mineralization or deposition is the work of osteoblasts. This is how we form bone. Ossification can sometimes happen outside of the skeleton. So sometimes this can happen inside of a membrane. One example of an ectopic ossification that you have is the patella, so your kneecap. And then mineral resorption is the opposite. This is the work of osteoblasts, so this is going to destroy bone tissue. So this is how bone is dissolved. And both of these are needed for everyday work in bones. To remove bone tissue, we use resorption with osteoclasts. To form new bone tissue, we would use osteoblasts. So take a moment and reflect on the process of bone elongation and what happens in each of those 5 regions of the metaphysis.